Hello everyone. We have completed our first lesson. So today we start second lesson. This is our first class of a second lesson, inverse trigonometric function. From the word trigonometric functions means we have to recall our knowledge of 11th standard. In 11th standard we already learned trigonometry. In trigonometry we learn about sine, cosine, tan, cot, sec and cosec, simple functions. Now what is the new thing here? Inverse trigonometric function means we have to find inverse of it. So before we start inverse, let's revise what we learned about inverse. In our first lesson, relation and functions, what we learned? That when inverse will exist if your function is 1 to 1 and on to. So first condition for existence of a inverse is the function should be 1 1 and on to. Okay, now let's check first that we start with our first function sine. Now we will check sine function is 1 1 and on to or not. Okay, what you learn about sine function? That sine function is always mentioned from r to minus 1 comma 1. These things you learn in which classes? In your 11th standard. Okay, we already discussed unit circle A, B, C and D. So this is your 0 degree, 90 degree, 180 degree, 270 degree. And when the circle is completed, you can say 0 degree also or 360 also. This way we already learned it. Now what is the coordinate of it? Unit circle means origin is this and unit means what? The radius is 1 unit here. Okay, if radius is 1 unit and this coordinate of A lies on x-axis means what? Its coordinate will be 1 comma 0. Now this is on y-axis. So coordinate will be 0 comma 1. Why I have taken 0 comma 1? Because this is also the radius. So if the radius is 1 unit, so you can write this also y part 1 unit. Now you remember this is on the left side of it. So negative coordinate and here also again same. Now these things you already, all these things you already learned in your previous classes. Okay, what we learned for sine function for 0 degree, for 90 degree, for 180 degree, for 270 degree or on 0 only you can write 360 degree also. So for that what you learn your coordinates, that sine 0 degree is, see when I write this way, then first is cos and second is sine. So sine 0 is 0. Now sine 90 degree is 1. Now sine 180 degree is 0 and last d, that is minus 1. Now from this what you learn? That here we are getting for the two different values, answer is same. What is the meaning of it? Sine 0 is 0, sine pi or 180 degree also 0. Similar way sine 360 also 0. So for so many different questions we are getting the same answer. What is the meaning of it? This is many one function. But what is our condition for existence of a inverse? That our function should be 1 1 and on to. Okay, let's revise these things with the graph so it will be more clear to you. What is the graph of sine function? Let me draw it. See, this is our y coordinate, y axis, this is 1, this is minus 1. Now 0 degree. Now we are making 90 90 only. 180 either I can write pi by 2, pi, then 3 pi by 2 or 270 and last 360 or you can say 2 pi. Similarly I can draw minus 90 degree or I can say minus pi by 2. Minus 180 degree means minus pi. Minus 370 degree, 270 degree or minus 3 pi by 2, that way. Okay, now we know sine 0 is 0. So graph passes through origin. First coordinate is 0. So I just mentioned the point. First is sine 90 is 1. So highest here. Sine 180 is 0. Same way. Sine 3 pi by 2 is minus 1 and at 2 pi this way. Similarly, At 90, minus 90, it is again 1, here 0, here minus 1. So what is your graph's figure? Figure will be like this. This way we can complete our chain. Let's extend this up to 360 degree. So you can draw like this. So what is the meaning of it? That our graph passes through origin, and this way we can complete our one cycle. Now check. Here 0 degree, here 0, here 0. So what is the meaning of it? This function became many one. Okay, now many one function means we cannot find inverse. So let's make it 1 1. Okay, to make it 1 1 function, what to do? We have to restrict its domain. Okay, in sine function we already discussed that its domain is R and range is minus 1 comma 1. Why minus 1 comma 1? Because on the unit circle maximum answer is 1 and minimum is minus 1. That means your function's range is minus 1 comma 1. Now we are writing, when we are writing for inverse of sine, then what to do? Okay, let's restrict its domain. So if we start with 0, then here 0 degree, and if we complete one cycle, if we take 0 to pi, then what we will get? For two different terms we get the same answer, so you cannot take. Okay, let's think about another one more way, that we are taking from minus pi by 2 to plus pi by 2. Wait. If we take from minus pi by 2 to plus pi by 2, then what you will get? By mistake we have drawn this way graph. This. Then what you will get? Minus pi by 2 means here, plus pi by 2 means here. So from that point you can say maximum answer is 1 and minimum answer is minus 1. So when you restrict your domain, then you can take only this much portion in which there is no repetition of answer. No repetition of a answer means from minus pi by 2 to plus pi by 2 we can write as its domain. If we draw in this, then we get with minus 1 to 1 answer and we cannot get the repeated answer. So if we restrict our domain from minus pi by 2 to plus pi by 2, then you can say it's became 1 1 function, and if became 1 1 and on 2, then definitely we can find its inverse. Okay, but the question arises, that's how we are getting from this to this. Similar way, this portion also same, this portion, right, this much portion. Here again you get the same answer. Same thing is repeated here also. If we consider only this much portion, then again we get the same thing, our function 1 1 and on 2. So we can definitely take all these terms also, but general we are taking that from minus pi by 2 to plus pi by 2, and you can take from plus pi by 2 to 3 pi by 2 also, from minus pi by 2 to minus 3 pi by 2 also. All this its principal domain, but in general we are taking from minus pi by 2 to plus pi by 2. So how inverse will exist and what is it? So when you write sine inverse, its values lies between minus pi by 2 to plus pi by 2 to minus 1 comma 1. But when you write inverse, domain became range and range became domain. So how can we write? Now I rough this graph and we will write in short how we can get. See, sine function we can write for R2 minus 1 comma 1. Now when you write sine inverse function, your domain became minus 1 to 1 and range became minus pi by 2 to plus pi by 2. First I have drawn graph, that is your which graph? Sine graph. Now we will draw graph for sine inverse. What is your graph for sine? It is same only, domain became range, range became domain. So only little bit change, that graph will be vertical this way. And now this is if 0, then this one is pi by 2, this one is pi, this is minus pi by 2 and this is minus pi. Now how can we draw? This figure is same, everything is same. At sine pi minus pi by 2 and at sine it is passes through origin only. At 90 degree the maximum value, that is 1, and here 0. So your graph shape will be like this only. This way only, and we are taking only this much portion, this one, this part, that is your graph. But if we draw full graph, then your graph shape will be like this. So what is the difference in sine and sine inverse? Here we are getting horizontal graph like this. One and minus 1. So which figure we get? This way. Shape of graph is this. Now when you draw for inverse, your graph will be vertical and your shape will be this way. So meaning remains same, but what you have to remember, that is our this thing. This is for sine, this is for sine inverse. If the concept of graph and concept of the domain and range clear, then only you can solve easy way the sum of it. Otherwise it's very difficult, because you all are afraid of trigonometry, and if you will not get this concept proper way through graph, then you cannot solve the questions. So how we have solved for sine? That what is the domain and range and what is the sine functions term. Say if you understand it, then only easy way you can understand for cos also. Okay, now for cos also the same concept we will apply. This is your A 1, 0, B 0, 1, C minus 1, 0 and D 0, minus 1. Okay, so what to do? 0 degree, 90 degree, 180 degree and 270 degree and 360 again same. Now cos means first term 1, 0, then minus 1 and 0. Now you check, again we are getting for the two different terms the same answer. What is the meaning of it? This function also many one. Now for many one, first we have to restrict its domain and then we have to make it 1, 1. Okay, let's draw his graph, and then first we make it 1, 1 and onto function. So what is its graph? I draw it first. Pi by 2 pi minus pi by 2 minus pi. Okay, now we already discussed that sine 0 is 1. So at 0 degree the highest point is 1. At pi by 2 it is 0. So here, and at pi it is minus. So what is the shape of graph? This way you are getting. So same thing will be follow on this side also. Minus. Okay, if we draw here 3 pi by 2, we extend this graph 3 pi by 2 and 2 pi. Then what will be? This. And at 2 pi we can stop like this. So this is your graph for cos. Now you check. Here 0 degree, here 0 degree, here 0 degree. So it's became many one. Now let's restrict its domain. So only we have to take a portion, curved portion, how we have taken in sine, only this much. So what is it? From 1 to minus 1. That way we are getting two values. So when you restrict its domain, this is 0 and this is pi. So when you restrict its domain, it became 0 to pi. How can we write for cos function? Cos function always written from minus r to minus 1, 1. But when you restrict its domain, cos inverse will be from 0 to pi and its term will be from minus 1 to 1. But remember, when you write inverse of any function, domain became range or codomain and codomain became range. So let's write it one more time for sine and cos both. I think graph will be clear to you, and same way vertical graph for cos also. Let's draw the vertical graph also, so it will be more clear to you. Here we can take 1 and minus 1. This is pi by 2 pi. This is minus pi by 2 minus pi. Now we can take sine 0 is 1, so point is this way you can consider all the points. So what do you get as an graph? This way, pi by 2 and at pi minus 1. So your shape will be like this. How we have get in cos? It's vertical graph for cos inverse. Okay, now we will make a table for it for sine and cos. You already know, we have already discussed for sine and what is the sine? Cos. First we have to write its domain, then you can say its range. So for sine and cos, domain is this and range is minus 1 comma 1. We already familiar with it. Now we are writing for inverse. So what is for sine inverse? For sine inverse, when you write for sine inverse, what is it? Domain and range. So when you write for sine inverse and cos inverse, what is it? Domain became minus 1 comma 1 for both one, and range will be here minus pi by 2 to plus pi by 2 for sine, and for cos 0 comma pi. Now remember, this thing is too much important as per as your inverse trigonometric concern. Why? Because inverse trigonometric function is, or trigonometric function is too much important for your differentiation also, for integration also, for integrals also. So whenever you solve these questions easy way, or if you have an idea of a domain, range and how to solve it, then only you can go through proper method for integrals and differentiation also. So this is the pillar, or you can say base of it. So do it proper way. You remember this table. Remember, for sine and cos, what is the domain and range, and when you write inverse, your domain became range and range became domain. That also you have to remember. But when you write for inverse, for existence of a inverse, the function should be 1, 1 and on 2. So you cannot make a r as its range, because we have to restrict its domain. When you restrict its domain, then it will be minus pi by 2 to plus pi by 2. So that way you are getting for cos 0 comma pi. So for sine and cos only I have explained these two things. Now remember, we have to take for tan also same as a sine, and for cot same as a cos. We will discuss it again. But before that, just you remember this table, and then now we can start for tan. Okay, now first I write for tan and cot, then sec and cosec. See, just now we are discussing about the single term of a tan, cot, sec, cosec and everything, which one you already learned in your previous classes. For tan, what we learn? R minus minus 1 comma 1. Either you can say where it's became 0, that term we are cancelling. See, tan means what? Sine upon cos. Cos means when your cos became 0, that term we are subtracting, and when cos became 0 for odd numbers and belongs to z, that way. And what is the answer you are getting? Answer always in r. Same way for cot also, when sine became 0, so for k pi, k belongs to z, and this is also for r. For sec and cosec, how can you write for sec and cosec? For sec again same, r minus, where sec means what? 1 upon cos, and cosec means 1 upon sine. But remember, r minus when you write, its range also will be r minus minus 1 comma 1, and here also r minus minus 1 comma 1. This is same, and this is also here same. So that way all these things which one I have explained, we have already discussed in our 11th standard. Now we will start with inverse of it in our next class. So for this class, I think this much is enough, and you revise it, all the trigonometrics, domain, range, everything in your 11th standards book. Okay, thank you.